Integers and the number line. For this lesson, we're going to explore some vocabulary words that we need to know in order to work with integers and the number line. The first vocabulary word is whole numbers. What are whole numbers? Well, whole numbers are all of the numbers that start at 0 and then count up. So you start with 0 and then you go 1, 2, 3, 4, and so on. And it keeps going. Now, whole numbers have something that's called opposites. And what those are if you have a number, let's say 1 has an opposite that's an equal distance away from 0, but it's on the other side, and that's what we call a negative number. So the opposites are going to be the numbers on either side of 0 that are the same distance away from 0. So the opposite of 1, for example, would be -1. And if you look at a number line, if there's 0, you have 1 over here, and then -1 there, and those are the same distance away from each other. The distance from -1 to 0 is the same as the distance from 1 to 0. So 1, the opposite of 1 would be -1, and the opposite of -1 would be 1. So a couple examples of opposites. You could have 3 and -3 would be an opposite. You could have 10 and -10. Those would be opposites as well. Okay, so you have whole numbers, you have opposites. Now, integers. What are integers? Well, integers are all of your whole numbers and their opposites, as well as 0. So integers, if you were to start listing the integers, you could start with 0 and include all the whole numbers. So 0, 1, 2, 3, 4, and it keeps going. And then it also includes all of the opposites. Now 0 doesn't have an opposite because 0 is the same distance away from 0 as itself. So the opposite of 0 would technically be 0, but it doesn't really have an opposite. So you have 1, and then -1 would be its opposite, and then 2, well, the opposite of 2 would be -2, then -3, and you keep going in that direction. So it's all of the positive and negative whole numbers. Well, whole numbers are only positive, but all of the whole numbers plus their opposites and 0. Okay, so that's integers. So there's positive integers and negative integers. Okay, and that makes up all of the integers. Okay, now let's look at what it means for something to be equal. Well, if something's equal, it's the same. So 3 would be equal to 3. 4 would be equal to 4. And you could write it differently. You could write 2 plus 5 would be equal to 7. But all of these things are equal. Now we want to explore something called an inequality. An inequality. And what an inequality is when you're trying to compare numbers that are not equal. So if I have two different numbers, let's say 2 and 5, and let me get rid of that comma. If I have 2 and 5, well, they're not equal. You can't write 2 is equal to 5. But we can write how they relate to each other by saying 2, and we'll introduce a new symbol here. It's called the less than sign. And it looks like that. Think of it kind of as an arrow. It's going to point towards the smaller of the two. Or you can think of it as the mouth of like an alligator or a tiger or something, and it's trying to eat the larger of the two. Okay, so it's either an arrow pointing at the smaller or like an alligator eating the larger. But you read it from left to right as 2 is less than 5. 2 is less than 5. And that's how you would write it out. And then you also have greater than. You could write 6 is greater than -1. Okay, 6 is larger than a -1. And if you picture it on a number line, if this is 0, and you have 1, 2, 3, 4, 5, 6. If 6 is over here, and -1 would be here, so if you're heading right, you're going in the positive direction. If you're heading left, you're going in the negative direction. And if a number is farther right than another number, then it's said to be larger. So 6 is greater than or larger than -1. And that's what we see down here. 6 is greater than -1. And like over here, and I'll put these on a number line, but I'll use a different color. The 2, and remember this one is 0 here. 2, which would be right there, is less than 5. So 2 is less than 5. And that makes sense because 2 is farther left. It's towards the minus. So it's less than 5. Now we could also write 5 is greater than 2, right? Because 5 is farther in the positive direction than the 2. Okay, now that brings us to absolute value. What absolute value is, well, simply put, it's the distance away from 0. So if you think of a number line again, think of a number line. Here's 0. The distance away from 0 is what an absolute value is. So what that means is that the distance away from 0 of 1, 2, 3, of 4, the distance from 0 of 4 would be 4. Right? If you're measuring a distance, and when you measure a distance, you don't measure it positively or negatively. It's always going to be, well, it's always going to be positive. You measure a distance as positive. If you want to say how far it is from your house, here's your house. If you want to say how far it is from your house to a store, let's say we have a store over here. From your house to a store, you don't measure that as, well, it's 5 miles to the store, but then from the store to my house, you wouldn't say it's -5 miles. You would still say that it's 5 miles. And that's how you can think of absolute values. So the distance away from 0 of 4 is 4, and also the distance away from 0 of -4 would also be 4. Okay, so the absolute value of -4, or the distance away from 0 of -4, would be 4. And you can count that as 1, 2, 3, 4. Okay, and the way we write absolute value in math terms would be with 2 vertical lines. So you would read this as the absolute value of 4, and that's going to equal 4. And then you could also write the absolute value of -4 would also equal 4. And you can add other things like the absolute value of -10. The absolute value of -10 would equal 10, because -10 is 10 units away from 0. So I hope you kind of have an understanding of what an absolute value is and what an inequality is. And in the next lesson, we'll show a little more examples. We'll show some examples of using these definitions and these concepts.